I'm going to get up here. I want to actually sort of be closer to the audience, but I know that if I don't want to move anything and I have to be able to read some of these things, so it feels a bit distant up here. Okay, so what we're going to do is I'm going to take you through a unit of work on the water cycle, okay? And just show you what some possibilities are for building up a good cycle, a good teaching and learning cycle around the water cycle. So we've got cycles going everywhere here, and hence the title, Cycling Through the Curriculum. So I'm going to cover this territory here. The first two I've already done fairly well, or I've done in the previous session, so we won't spend much time on that. The third point is going to be the point of focus, building students' literacy capacities through an explicit teaching and learning cycle. So we're going to have an opportunity in this session just to kind of, slow down apart from anything else, but also to step through the cycle and see what it might look like in a classroom. Okay, and maybe I'm not the one to do it. When your place is all over the head, a dare fix will fix it. Okay, this is one of the coffees in Australia. All right, and we've seen how this literacy is a capacity to make meaning across the learning areas. So we've taken up that whole issue, and we've seen that we can make these meanings across all of these learning areas, and we want to know what can we teach about the meaning-making resources. Keeping in mind that we can make meaning through language, through visual representation, and through mathematical symbolism. We're going to focus on the first two in this one here. We're going to focus a little bit on language, not a lot, but a little bit on visual representation too. Now you've got a handout there in front of you, and so hopefully that's kind of useful as we move through this workshop. All right, if we have a look at this text here, you haven't got this text on there, but it's a water cycle text, and you can see that it consists both of language and visuals, yeah? You might be tempted to say that the language is more important, yeah? A science teacher might be tempted to say the visuals are more important. I think the better position is probably that they're equally important and they're both doing work here. So if you look at these visuals here and you look up, for instance, you look up at these things here, what do these lines here mean, these squiggly lines? What does that mean? Squiggly lines like that, what does that mean? It means evaporation, does it? How did you work that out? For all this, you've seen it before and you've got some idea of what's going on in this text, but really it's just a red squiggly line, and it could mean potentially anything. If we go into other aspects of it, you can see this arrow here. What does that arrow mean here? What is this little cloud, that bigger cloud, and that big cloud? What does that mean? What does it mean, though, in terms of what's happening in the water cycle? The clouds are growing. Does that make sense? And yet it looks like three sort of harmless little clouds, mother cloud, baby cloud, and papa cloud, doesn't it? It looks pretty neutral. And so all of these things are at stake here, and you can go through this diagram and see that there's a lot of meaning being made through the visuals that you might think, and we can easily think that the students are getting it. They miss a lot. They miss a lot of the meaning making that goes on in visuals. Yeah? Okay. And then in the language itself, we can see, most obviously we can see in the language, we can see in the technical words. They're the ones that are sort of most obvious to us that give the students difficulty, but it's much more than that. It's also built into the grammar and the structures as well. Meaning making in mathematics, language, there it is. Visuals, there. And then the symbolic here, and you can see how technical that symbolic gets. Here's a bit of meaning-making mischief. Find X, here it is. Expand. Okay, the student expands. All right. So we're going to have a look at this teaching and learning cycle around the water cycle and the setting the context stage. Here we're showing students what will be learned in this cycle, building on what they already know and engaging the students through activities that draw on their common sense understandings, right? So this is a good starting point for any unit of work. In the modelling and deconstruction stage, here the teacher's taking on the role of expert, modelling how to carry out the particular skill or capability under focus, pulling apart in a meaningful way the text the students are expected to read and write, and developing a shared meta-language, a language for talking about language with the students. And then in the joint construction, the teacher's working with students to jointly undertake the particular skill or capability under focus, and in making explicit the processes involved in producing a text by continually scaffolding the students through ongoing micro-interactions. Okay, so as I said in the plenary, this is really tough territory for teachers. I've been working very closely with teachers in the last couple of years. I've been going into a lot of classrooms, observing teachers and talking to them afterwards about what they've been doing and so on. And the teachers love it, by the way. The teachers I've been working with are very happy with that if you're very fair with them, if you're fair about what they're doing and so on. And everybody agrees this joint construction territory is very difficult territory to do well. Yeah? Very difficult. Okay. So then the independent construction, supporting our students to undertake more independently the particular skill or capability under focus, given the nature and depth of the earlier part of the cycle. So, if we want them to produce something at the end, then we have to have a rich curriculum cycle that helps them to build that capacity. All right, so, in this one here, we're looking at writing a sequential explanation of the water cycle. And, as we move through, the students are going to move to independence, but the teacher must hand over control. This is part of the deal. We've got to find a way of giving over the control that we have and the knowledge we have to the students. And this is really difficult to do well. And the students have to take increasing control. Okay? All right. We've seen the functional model of language. I'm not going to go into that in any more detail here. But we'll pick up elements of that as we move through this next part here, especially this register continuum here, this idea of moving across it here. All right, so away we go. We're looking at building a macro scaffold for learning about the water cycle. And we can use this teaching and learning cycle to provide students the macro scaffolding for learning about the water cycle. And all the activities are aimed to build the register, to build up the register of the text the kids have to produce at the end. So they're going to write about something, some topic, here the water cycle. They're going to write as scientists, so their roles is semi-formal as a scientist, and they're going to write it in written mode, right? So that's the kind of shift that we want them to undertake. All right, let's have a look at some of the activities. I would begin by showing a structured overview of the unit of work on the water cycle and where it fits in with the science curriculum, and identify the focus genre, in this case, a sequential explanation of the water cycle. So this is from the Australian curriculum, but you'll find this in the English curriculum. Most science curriculums sort of cover the same territory, and you can see here water is an important resource that cycles through the environment. See that? So, the curriculum is saying this is a good thing to do. And the focus genre is going to be a sequential explanation of the water cycle. Now, I think you've got, have you or haven't you? Yes, you have. On page 5, if you go to page 5 of your handout, you've got this text here, right? The water cycle. And, what you might decide to do in this particular cycle is you might decide that you're going to co-construct the first part of it, right, with the teacher and students, and then let the students complete the last part, the last 3 paragraphs. That's possible. They don't have to do the whole text. You let them do what they're going to manage to do. But you're showing them what you're expecting them to do. So the students know that this is the expectation that they have to do at the end of the unit of work. All right. Introduce the topic by showing students a simple diagram of the water cycle with the 4 main phases and discuss broadly. Discuss with students previous work done on life cycles and reflect on the purpose sequential explanations. So if we have a look at this, and you've got a picture of this on page 4. If you have a look at this picture here, you can see a lot of directionality going on in this picture, can't you? Can you see the arrows? Like the first arrow you kind of hits you is probably that one on the right, isn't it? Where it says evaporation. Can you see the one I'm talking about? This one here. This one here. Yeah? And then where does the direction go then? What happens as you come up here? What happens? You're going along here, aren't you? What happens then? You're either coming down here or there, and let's ignore these for the moment, but then you've got the runoff here. So what you can start to see already and what you could start to explore with the students is this notion of a cycle, right? That's a cycle. And this cycle goes around and around and around and around. What might be useful to explore with the students is what's something they recycle in their lives? What examples will they give? Paper, okay? Paper? Plastic? Yeah, plastic one would be a good one to start off with. Holding up a plastic bottle, I haven't got one here, or this plastic cup. How is that recycled? And really teasing out with the students what happens to the cup. Okay, you put some water in, you drink it. Where do you put it then? What would they say? Come on, be students with me. They put it in the bin. What bin are you putting it in? The recycle bin. Okay, what happens to the recycle bin? Someone comes and picks it up. Where do they take it? They take it at the recycle centre. What happens at the recycle centre? It's separated into particular kinds of plastic and other waste, right? What happens then? It's ground down into little bits. What happens then? Yeah, you can see what I'm doing here. I'm really teasing out this notion because eventually what's going to come back in my hand? The plastic cup or the plastic bottle. Does that make sense? So you're already exploring this notion of cycling and recycling through their own, through their own worlds, through their own experience. Because you can't see the water cycle going on. Can you? I mean, you can sort of experience it when there's rain coming down, I guess. You kind of know that the water's come from somewhere, but you can't actually see that cycle going on. It's just an endless sort of thing that happens. The puddles of water form, the water evaporates and goes, All right. Read about the finite nature of the water cycle. Have a look at page 2. This is from the textbook. This is from a textbook. This is used in some of the schools back home. It's not the only science book. It's a pretty good one, I think. It's fairly comprehensive. But you can see the paragraph there that says the water cycle. Can you see that? What's the first sentence say? Read it out. Come on. The amount of water on Earth is finite. What does that mean, finite? There's only a certain amount of water. You agree? Is that worth pursuing with the students? What do you think? Is that something worth kind of going into if you're doing the water cycle? I think it is, isn't it? Because we know this water's going around and around, so we want to kind of look after it, don't we? We don't want to be mucking it up too much, right? Because what comes around goes around, yeah? So to give the students a notion that this water is the water you've got in your pure Evian water bottle was once somewhere else, is a very important thing. Okay, so let's have a look at that. Next thing. Carry out a series of demonstrations that show the processes of evaporation and condensation. Okay. How could you do that? Well, I'll suggest a couple and maybe you can suggest some more. Okay, here's one. Boil an electric kettle. What's going to happen when you boil the kettle? This becomes interesting, doesn't it? So the students are going to say, what's happening here? What's happening here? They're going to say, steam. Yeah? Scientifically, that is not steam. Yeah? Scientifically, these are water droplets, right? The steam that we can't see is the water here, is the water vapour. Does that make sense? So the water's turned from a liquid into a vapour, and you can't actually see water vapour. You can only see it when it condenses and turns into little tiny drops. And that's what people commonsensely call steam. Does that make sense? Yeah? So if we're doing something on the water cycle here, we could explore whole lots of meanings about the water is heated inside the kettle, the heated water comes out as water vapour, and then the water vapour cools and turns into tiny water droplets. So you can see that such an activity would provide lots of opportunities for you as the teacher to construct those kinds of meanings that we've seen up there. Not just say them, but co-construct them with the student and press. Pauline Gibbons uses the word press. Press the students into using them. Get the students saying those things, right, as a precursor to them writing it. Yeah? What's another thing we could do? Well, we could boil a saucepan of water. Yeah? And we might see what would be coming out the top. What are we seeing up here? Careful. Condensed water droplets. Yeah, it's not steam. It's condensed water droplets we're seeing here. What if we put a lid on it? What's going to happen? Let's imagine it's a glass lid. What's going to happen on the glass lid? What are we going to see? Come on. We're going to see little bits of water forming drops, aren't we? Big drops, and it's going to run down the side and so on. So we know that as, familiar with the territory, we would call that condensation, wouldn't we? We know that the water is the hot water vapour is hitting a cooler surface. This is condensing the water vapour into water droplets, right? And so, okay, here's another thing we might do. Stretch a rubber balloon over an empty bottle and place the bottle in a saucepan with very hot but not boiling water. The balloon will start to rise. Explore with the students what is happening here. What is happening? The hot air, the hot water vapour is rising, right? It's rising. Why is that so important in terms of the water cycle? Because that's what's happening, doesn't it? With the water vapour, when the water is, forms a little bit of water, forms a puddle, so if we can come along here and I can go like this, I go like that and spread some water there, then by the time I finish my talk here today, that's going to be gone. Okay? So what I could do is I could I haven't got my mobile phone on me, but I could get my students to take time-lapse pictures of that, couldn't they? Yeah? And then they have to explain it. What would they say? It's dried up. That's common sense. It's dried up. But if they have to move into scientific explanations, what's happening to the water as it's sitting there? What's happening to it? It's starting to evaporate, isn't it? And it's evaporating because it's actually warming, the molecules are moving and so on. So we can start to explore all of those things with the students. Yeah? Can you think of anything else you could do? Anything else you could do with... There's one thing, with the evaporation, you could do time-lapse photography. You could do it with puddles, couldn't you? Yeah? Puddles outside. You could get the kids to go and over a week they could have a puddle, although, maybe in the middle of winter it's going to rain and the puddle is going to be there for the whole of winter potentially, but it might dry up. Any other thoughts? What could you do? Yeah.
One year I wrote condensation on my mobile class window.
Yep.
The windows weren't clean for a year. They reappeared every year.
Is that right?
Yeah. The class was getting up and we all got a bit hot.
Okay, that's good. Yeah, that's great. Okay, you could do lots of activities with steaming up rooms and getting, think about all of the kinds of contexts where we see water vapour. We don't see water vapour, but where there is water vapour and we see it condensing into water droplets. So there's plenty of other contexts that you could think of. All right. What can we do now? Recast students' attempts to describe what is happening when water evaporates and condenses, focusing on the use of technical language and nominalisation. So this nominalisation we just went through very quickly, and I'm really sorry about that in the presentation, but basically turning verbs into nouns, verbs and adjectives into nouns, right? And then locating on the register continuum the more written versions. So we've got an example here. So what we would be doing is already we would be pressing the students to co-construct this with us. So as the water is heated, okay, what happens to the water as it's heated? Okay, I'd be going like that. What's your name? Sue. I'd be picking on Sue. Sue, tell us what happens as the water is heated. What am I doing by doing that? I'm pressing Sue into giving me an explanation. She's got to come up with the next bit. It evaporates. Does that make sense? I'm not asking a question, okay, who can tell me what comes next? What happens then if I do that? The hands go up. Sue never puts a hand up. She just sits there. She's quite happy just to sit there and, under the radar. But by my pressing her and naming her, she's going to give me the rest of it. Does that make sense? So we're kind of pressing them into this thing here. Now, if she doesn't know the answer, okay, we'll come back to you, Sue. We'll come back to you, Sue. What's your name? Chris. Chris, help us out. Chris does know the answer. Okay, Sue, tell us what happens. Yes? How do I know? You know your students, don't you? Yeah? You've got a fair idea of which kids know and which kids don't know, and how to bring them in to the lesson without embarrassing them, without terrifying them. If you build up that kind of context, that kind of rapport with your students, the kids won't worry at all. They'll be happy to make mistakes. They'll be happy if they don't know. I'm not sure. Yeah? Does that make sense? It's yeah. You're going to...
Yeah, I was just going to say, I watched a maths teacher last week.
Yeah.
And he had such high expectations of his kids. He used that technique that you were talking about. And it had become part of the culture of the
Yes,
class.
yes, that's right. That's
not knowing the answer was not a problem.
No, that's right. That's right. It's not an issue.
It just became, you would be asked,
Yeah.
so you would participate on whatever level you could.
Yeah.
But what it did was it set the expectation up in the
Yep.
minds of the students that they would be accountable for what they learned.
Yep.
So they paid more attention.
Yep. The best teacher I ever saw was a teacher, Sandra. Somebody here is going to Robert College soon, but Robert College in Istanbul. She's the best maths teacher I've seen. She had a list of cards of all the kids in her lesson, and she had them on the desk, and she'd just go through the cards. And these kids, they were jumping in her class. They just couldn't wait to... They didn't get embarrassed when they were called at all in any way, shape or form. If you followed that class into the next class, that didn't happen, and some of them would just... They'd go very flat. Do you know what I mean? So it's a very... But she'd built up the culture in the class. If the kid didn't know the answer, there was no sense of shame or anything, in that. So, okay, so what we noticed there, can you find a verb there? We've got two verbs. We've got is heated, and the other one is Evaporates. Okay, let's turn evaporates into a noun. Evaporates is the verb. Noun would be evaporation. Okay, so you can see there's an opportunity to start looking at this, because eventually the kids, when they write their texts, have to write about evaporation, don't they? They're not going to talk about the world in verbs all the time. Eventually, they're going to have to use evaporation. And you can see in this one here, you can see here the water vapour rises, it cools and turns back into water droplets. So it rises and cools and turns back, becomes it. The verb would be condenses, and then the noun would be, this is condensation. Yeah? Okay. Yep. Just speak up a bit, I can hardly hear you.
You've gone from turns back
Yeah.
to condense,
Yes.
which means you've gone from
Yep.
phrasal verb
Yep.
using Anglo-Saxon.
Yeah. You've done a Peggy McNeil on me, which means you've jumped in before I've come to the next slide, right? So if we take evaporation as a nominalisation and then turn it into a verb, what's the verb for the noun evaporation? Would be to evaporate. What does to evaporate mean, though? It means to change from one liquid state to a gaseous state. That's pretty technical still. Let's unpack it and take it a bit further over, and we get something like that, yeah? Let's shift it a bit more, and we get something like that, right? So we can go both ways here. As the teacher, we can go from this more written, technical language, slowly unpack it for our students and bring them over here. And what we've been doing in the classrooms is the kids are writing that down. They're writing all of it down on their register continuum sheets. So it's not a kind of a thesaurus they end up with, a glossary. They end up with a kind of thesaurus of meanings, right? So the kids have got all of those meanings at their disposal. And then we can come the other way. The sun warms up the water and turns some of it into water vapour. The sun evaporates the water and turns some of it. This is called evaporation. So I think that's kind of slightly answering your point, but you know, it shows you the complexity of the linguistic shifts that are going on there when you do such moves, doesn't it? Yeah? Okay. Show a video of the water cycle. How are we going? Got a few more minutes. Show a video of the water cycle. Now here's a video of the water cycle. I'm not sure if this sound's going to come through. It doesn't really matter. It's not crucial to the whole thing, but I'll just play it through and see if you can make any sense of this. Here we go. Okay, you get the drift, don't you? Yeah? What's happening at the beginning? What's this thing here? What's this little, sort of looks like a bit of pollution going on here. What's happening there? What's that representing? Yeah. Okay? Now, if we go on a little bit, we see something here. Look at this. What's that? That's the sun. Why are they showing the sun? Why is there a close-up of the sun? Because that's where the energy, the heat energy is coming from, right? To start the cycle. Okay. Oops. Sorry. I've got to just... Okay. Okay, what's this? What's this little red thing there? This red thing with two sort of eyes there. What's that? It's a molecule of water. Do you reckon the kids would understand that it's a molecule of water? Not necessarily, especially if they've never studied molecules before, right? So you'd think, well, to understand this diagram really well, you've got to get down to the molecular level, which is a bit challenging. What's the red line mean? Why is it red? Why is it red? It's heated, right? It's heated. What about the blue one? What's the blue one doing? Cooling. Okay, yeah. What's the black one? It's rain. It is, isn't it? It's rain. And if we keep going with this, okay, you get the idea. So what we're doing is we're looking at a water cycle, even though it's quite a complex little video, by stopping it and exploring all of the meanings that are coming out of it, it's going to be very helpful for the students. Yeah? Okay. So we can then move into a model text. If we have a look at the model text just on page 5 here, if we sort of looked at the life cycle of an ant, which is also a sequential explanation, we could deconstruct that with the students. So here we're modelling and deconstructing a sequential explanation. And you can see that, you know, we're focusing on the structure, we've got the phenomenon identification there in that first thing here, and then an activity sequence. That's the broad structure of a sequential explanation. But then the phenomenon identification itself can have more than 1 or 2 or 3 or 4 phases. Here it's got a title and it's got an outline of the main stages. Yeah? And then each of those stages you can identify as the egg stage, the larvae stage, and pupa stage and adult stage. So we're kind of pulling apart here the structure of a sequential explanation. If we have a look at our water cycle, we could do the same thing there, right? We could pull apart the structure, the main stages, and the various phases of that. Okay, because the kids have to write this thing in the end. They have to know what the structure is, what it looks like. And then we can move to deconstruct with students a model of a sequential explanation on the water cycle, showing how the visuals and the language and the text are working together. Okay, this is the last thing we'll do here. But if you have a look at that on page 4, if you have a look at the visuals, what we can start to do is to connect the meanings in the visual text with the meanings in the language, in the verbal text below. All right, so for instance, if we have a look at, it says here the amount of water in the environment remains constant because it's always changing state. It is continually moving through a natural cycle. How could we connect that natural cycle to the diagram? Think about what we did earlier on. What did we do? We put in that circle, didn't we? Yeah? So we're connecting that. We're saying this cycle here, and we're talking about it in the language here. Okay. In this cycle, water moves through 4 main phases: the evaporation phase, the condensation phase, the precipitation phase, and the collection phase. Can you find anything in the visuals that connects that to the wordings there? So the evaporation phase, can you find that in the text? Where is that in the visuals? Can you see the word here? Look, here it is. See the word? Evaporation here, yeah? So I would draw a circle around that and I would draw a line to that, yeah? The condensation phase, how does that connect to the visual? Okay, so draw a line around that, or a line connecting those two there. The precipitation phase, where's that? We've got 2, haven't we? We've got one there and one there. Okay, the collection phase. Where's that? It's not there, is it? Is it there? Can you see the words collection phase anywhere there? Collection? It doesn't say it. What does it say? It says runoff, doesn't it? Yeah? So the visuals and the language here are kind of generally working together, but you can see how sometimes it goes a little bit skew. Okay. The last thing, in the evaporation phase, the solar energy evaporates water from the oceans, lakes and rivers. Circle the word evaporates there. Circle it. If you've got a green pencil, circle it in green. I'm going to ask a question. What evaporates water from the oceans, lakes and rivers and even puddles formed after rain? What evaporates that? What's the answer? Solar energy. Okay, circle solar energy. And how does that connect to the visual? The sun. Where does it say that? How do you know solar energy connects to the sun? It's your knowledge already that you're bringing to the text. For a lot of our learners, they just simply don't make that connection at all, let alone our EAL learners who may not know those words in their language, right? If it's Italian, it might be energia solare, it might be fine, but if it's another language like Chinese, it might be completely different wording. Does that make sense? So we're working very hard here to make these connections between the language and the visuals. And all of this work is going to pay off. When we add it all up, when we add up all of these, and then we can start to, even if you like, to get really fancy, is to start to put the first paragraph in a circle like that, and then you've got all the phases that you connect with the various parts of the text. You know, you can see that you've got the phenomenon identification, the evaporation phase, condensation phase, and collection phase. You can see that we've got the kind of visuals and the language working very closely together now. Okay, so, you know, just to finish off, you could do some other activities in the joint construction stage. So co-constructing with students, the phenomenon identification stage, and then the students would eventually do this. Now, if they did all of that work, and this would be work that's taking place over, I don't know, how many lessons do you think all of this would take place? Let's say a 1 hour lesson. 5 or 6? Yeah, 5 or 6 1 hour lessons. You can see that the students, by the time they get there, they're going to be really confident about writing this text, right? So if we can build in these stages, you know, into our curriculum cycles, these kinds of scaffolding, this meso-scaffolding in particular, the students are going to produce much richer texts, much better texts, much well thought out, more well thought out texts. Okay, so we got the water cycle. Okay, that's it. Let's stop there. Because it's 4 o'clock, I'm stopping right on 4. I hope that's been helpful, but I hope you could apply this to any topic at all, really. But this teaching and learning cycle has been incredibly productive in the context that we've seen it used and used well, especially when we get these rich curriculum cycles that engage the knowledge that the students have to do, but also engage the sort of language and the visuals and the meanings of those as they go along. Okay, I don't think we've got any time for questions, have we? No. Yes. So, if you've got some questions, put them down. We're going to have a plenary session, it seems. And
again. If you got any questions in mind, just write them down the pads and hand them to me as soon as possible, please.